All right, so the objective for today is identifying the difference and calculating independent and dependent probability. So you have already done basic probability and joint probability with conditional when you did Venn diagrams. And so independent and dependent probabilities are kind of like a mixture of both, a little bit of basic and a little bit of conditional, because you'll see the difference. So in your warm-up, you were asked to find the difference or describe the difference of independent and dependent. And now we're moving on to actual probability events. And so two events could be independent or dependent. The first one is independent, is if the probability that event A occurs does not affect the probability that event B occurs. Okay? So what does that mean? Here's an example. Flipping a coin and then rolling a die. Do those two events have anything to do with each other? Do they affect each other's probabilities? No, so they're independent events. Okay. Another event is drawing a card and keeping it. So this is with replacement. What does that mean? That means you put it back. With replacement means you put the card back or the marble back. Sometimes they do a bag of marbles. And so if you put it back, then you're not changing the probability. Okay? It's independent. So if independent events are with replacement, what do you think is dependent events? Yeah. Without replacement. So key phrase is when it says you keep it. And for this, the probability of event occurs does affect the probability that event B occurs. Okay. So you know if when they ask you pick a card and they tell you put it back, but then there's some where it's like pick a card and keep it. That's the difference. Okay. All right. So an example would be drawing a card and keeping it. Okay. So the goal for today, remember, is identifying if it's independent or dependent first, and then we'll do the calculations. Yes?
What if it doesn't say either?
Yeah, so like just two random events. Then you just see if they correlate with each other. So like, you're going to sixth period in the next class, right? Does that correlate with someone buying Chick-fil-A on Fairmont? No, they're separate events. Independent, yeah. So here's an example. Number one. Jeremy took his English test on Monday and scored a 77. He took his math test on Wednesday and scored an 80. Is that independent or dependent? Independent. One test was on Monday, the other was on Wednesday. One is English, the other is math, so wait. Not the same. Okay, you choose one card from a deck and do not put it back. Then your friend chooses one card from the same deck. Dependent, because the card that your friend chooses will depend on the card you took out and kept it, so it is dependent. All right, Chris's basketball team is in the Final Four. If they win, they will play in the championship game. Dependent, so They cannot be in the championship game unless they win. So the key word here was if they win. That's the condition. No. Huh? Yeah, but it's just determining if they're independent or dependent. So they do depend. Like, yeah, if they're not good, then they're not going to go to the championship. So it's dependent on their skill and if they win. Number 4, you roll a die and it lands on 4. You flip a coin and it lands on tails. Independent, separate. Okay? Alright, turn the page. So first step is identifying. Now is actually calculating. So when we calculate these type of probabilities when there's 2 events, 2 or more, you find the probability of each one and then you multiply them. And I believe you may have seen this in a Delta Math already. Maybe not if you did your warm-up. Was it on Excel? So here's an example. Number 1, you roll a die and get a 4. Then you spin the spinner and it lands on a number greater than 2. Is that independent or dependent? Independent. The die and the spinner are separate events that do not depend on each other, right? So what is the probability of rolling a die and getting a 4? 1 out of 6. There's one side that has a 4, and there's 6 total sides, right, on a cube. Okay. What about this spinner landing on a number greater than 2? How many numbers? 6 out of 8, which is 3 out of 4. Same thing. If you want to simplify before you multiply, that might be easier. But either way, you can simplify 6 over what? 48. Which is 1 over. Okay, can someone go calculate that decimal, please? Yeah, we always do fraction, decimal percent. 125? Good. Alright, so then that's 12.5%. Okay. Alright, let's do the bag of marbles. It says 3 green marbles, 2 blue, 7 yellow, and 6 red. How many total is that? If you add them all up. 3 plus 2 plus 7 plus 6, 18, yeah. Okay. Alright, A, what is the probability of choosing a green marble, putting it back? So is that independent or dependent? The in. It is independent, good. Because we put it back. Alright, let's calculate choosing a green marble out of the 18. How many are green? Good. And then we put the marble back so the sample space remains the same. The total is still 18. And now what is the chance of getting red? 6 over 18. Let's simplify both of these because 3 and 6 are both divisors of 18, right? What does this simplify to? 1 over 6 and then 1 over 3. So the 1 over what? 18. If he would not have put it back, good question. 6 over. Yeah, you go down 1 because they kept it. So 17.
Oh, okay.
Yeah, that's all that changes.
So it'd be 6 over 7?
Yes. The total changes.
1 over 18 is 0.05555.
Repeated? So 0.056. Don't say it. Did y'all hear my high five joke?
Yeah, I heard that.
It wasn't really my joke. I just saw it on TikTok. Yeah, what is it, Sebastian? Look, not me writing
Oh,
something.
yeah, I just saw a fly and I came
High five, up, down low, up in heaven. I say it so that my son can get embarrassed. He's 7. He was 364 days times 6. Okay, what's the probability of choosing a green marble, keeping it this time, and then choosing blue? So the green marble, we already did it, was 3 over 18, right? But we kept it, so the sample space goes down 1. 17. So we're not taking 3 out, we're just choosing a green one. 3 is the probability of getting it, yeah. Yeah, good question. Why is it now not down 3? Why only down 1? Because you're only choosing a marble, not 3 marbles. So 3 is not the number you're taking out. It's the possibility of getting a green one first, right? And then you kept it, and now they want to choose a blue one. How many blue is there? 2.
Mrs. 9 not a prime number?
No. 9 is not prime. Prime can only be divided by itself in 1. 2, 3, 5, 7, 11, 13,
What can 9 be?
17, 19, 23.
All 3 times 3.
Okay, 3 times 2 is... I don't know. 18 times 17. Good. All right, let's simplify that. We can divide that by 6. So this decimal is going to be small.
0.011.
Yes. 0.2. All right, how do you feel? You okay with independent, dependent?
Yeah.
Let's do 3 more with some cards on the back. Can I go forward? Oh, yeah. I wonder when it'll die down. It won't die down until the next trend comes out. Oh. What is it? Okay, here's a standard deck of cards. Remember, half is red, half is black. And how many are in total? How many total cards is there in the deck? 52. Okay. So we're going to use this standard deck to answer these independent and dependent questions. What is the probability of drawing an 8, putting it back, then drawing an ace? 4 out of 52 for the 8. What about drawing an ace? Again.
So 4 out of 52 squared.
put it back so it doesn't change.
So you only put it back if they keep it.
Yeah.
Say that again.
I said it's 4 out of 52 squared.
Oh, yeah. Yeah, because it's the same. All right, what is 52 squared?
52 squared is.
Come on,
2071.
pre-P students.
2007.
And 16
Of course I do. High expectations, high rewards.
I
Point
expect
zero
money
005.
leads to disappointment.
It's just 0.5%. 0.5%.
1/2?
No, it's 0.5%.
Isn't it
So then,
0.06?
point zero. 0.5%. What? No, 0.5%.
0.6.
0.5%.
Thank you.
0.006. Point.
Bless you. All right, number 2. What's the probability of drawing a face card without replacing it, then drawing a 7 of diamonds? So how many face cards is there? Only faces. 12. Good job. 12 out of the total. What is a face card? Yes, king, queen, and joker. No ace. Ace doesn't have a face.
It's different than the numbers, right?
Yeah,
It's not base.
it's an ace.
Very few,
Yeah. 3 times 4? 12. And then without replacing it. So we no longer have 52 in the deck. How many?
51. 51, but I got 51.
And then, well, how many 7 of diamonds is there?
2. 1.
2 or 1? 1. All right, can somebody calculate 52 times 51? Or just subtract 52 from the previous.
Yeah, 2652.
Thank you. That was for both of you. All right, let's approximate that decimal. Make sure you round to the 1,000. So look at the number after.
5.
Good.
5.
You get those Galapagos diagrams?
Oh, I get that. That's confusing. Sometimes it's confusing though. Like the what? Like you weren't actually using the total.
Right. Let's figure out the sections.
If that's gonna be on like this, this is gonna be
100. 100.
That's what I accept though. I was just start with it. Because they're just work problems. Like I did 2 already.
Who doesn't?
Only for the calculation. Like how here, see how we're doing
So
it?
like,
Right. There you're just identifying. You don't-
so I don't have, okay.
Okay, what is the probability of drawing a numbered card greater than 5 without replacing it? Then drawing a red queen. A numbered card greater than 5. How many of those is there? So above 5, so from 6 all the way to 10. No, we don't count the joker. 28?
Because it would also be the king and queen.
No, only numbered cards. 20, yeah. 5 times 4.
For me.
And then did we put it back or did we keep it?
Keep it.
How do you know we kept it?
Now we take it.
Good. And then how many red queens is there? Half are red, half are black. So how many? Good, 2. 20 times 2, 40. And then we already have this number from the previous question. What can we divide both of these by? Yes. Divide by 4. Yeah. All right, we're going this on page 27.